Good afternoon, everyone. My name is Ellen Shiner from First Parish in Bedford. We'd like to welcome you to the Bedford Lyceum. We have monthly free lectures open to the public. No pre-registration is required. And you can go on the uubedford.org website to get the Zoom link each month if you want to join us again. This program is being recorded. If you make any comments during the Q&A and you feel compelled to have us remove those before we post this recording to YouTube, you can contact me at mountainbreeze52@gmail.com, and that is mountainbreeze52@gmail.com. So let's start the presentation. I wanted to introduce our speaker, Alan MacRobert, who is an editor. Is that fair, Alan? At Sky and Telescope magazine. He'll be speaking about life in the universe. So where are they? And let me just give an introduction. Most of you have already seen this. Alan's been covering the SETI beat for decades. The searches are better than ever. Planets are abundant. Life seems to start quickly. So why haven't we found ETs yet? More pressingly, why haven't they found us? A life-covered Earth has been sitting in plain view of the galaxy for at least 400 million years. Alan has been a writer for Sky and Telescope magazine in Cambridge since 1982. He became fascinated with the deep paradoxes regarding life in the universe when he read Carl Sagan's Intelligent Life in the Universe when he was aged 14. In addition to his keen interest in SETI, that is the search for extraterrestrial intelligence, Alan's specialties at Sky and Telescope magazine include astronomical research news coverage and articles about upcoming celestial events for amateur astronomers. He's also been a science correspondent for the Boston Globe, where he's written their monthly Skywatch column. Is that still ongoing, Alan?
No, the shrinking Boston Globe decided this was, compared to the other news going on in the world, not the best use of space. So no more.
Well, Alan, one other thing to add, Alan in Sky and Telescope has a weekly column called This Week's Sky at a Glance, so you can check it out.
And that's on our website, skyandtelescope.org.
Great. So take it away, Alan. And we'll have a Q&A portion after Alan's presentation. Please hold your questions till then and don't forget them. Okay, Alan.
Okay. Well, thanks for that very nice introduction. You've covered my first card right away. So there's that, that's done. Well, to give some background, to get started. Now, throughout history, opinions about whether there is intelligent life on other worlds has swung back and forth for many times. With no data, opinions are liable to go flying one direction and flying another way, and we see this oscillation back and forth. Way back, people didn't know that there are other worlds beyond Earth, and although some ancient Greeks did suggest there probably ought to be, and so, of course, they had to be populated like our world is, or what would be the point? Once people realized that the Earth is a planet like the other planets, and there are other planets, it was sort of assumed that all of them, Mars, Jupiter, Saturn, would all be populated, and this idea reached its peak more than a century ago, after bubbling along in the background when telescopes weren't really good enough to show much of anything very well, until about a century ago when a Boston's own Percival Lowell, a leading astronomer, announced that Mars had artificial canals, and he'd seen them. And he went on a great campaign of books and lectures popularizing this idea of a Martian civilization. He founded Lowell Observatory in Arizona, and he had one of the biggest and best planetary telescopes in the world, and he was regarded as authority. He made Mars the thing in popular culture it is today. When somebody says, "Oh God, that idea is from Mars," the reason they say, "Oh, that idea is from Mars," rather than "that idea is from Saturn," is because of Percival Lowell more than a century ago, who made Mars a pop culture thing. But by the 1920s and 30s, astronomers with other telescopes than Lowell's had shown actually that the canals on Mars were an illusion, and Lowell was out to lunch. And there was such a reaction against that, about that embarrassment for astronomy, that life on other worlds became a disreputable topic in science for the next generation or two. And that trend was aided by the thousands of loud claims by UFO and alien abduction enthusiasts, starting with the first big flying saucer flap in 1947, which invented the word flying saucer. That all of these things never led to anything but mistaken identities or outright hoaxes or tale-telling, or just to nothing in particular. Just, somebody saw a light in the sky and then the light wasn't there, and what do you do with it? Nothing more. And nothing ever anything solid. They never landed on the Washington Mall and got out and got on television where everybody could see them and see that this was for real. And actually, 32 years ago, I wrote an article. I was very interested in UFOs, if I'm going on about this, back when I was younger. And I finally wrote an article in 1979, basically saying that if nothing had come of ufology, UFO studies and reports in the last 32 years, that probably means you could sit out the next 32 years of UFO studies and not miss anything. And now, here in 2021, I can say, since nothing has come of this at all in the last 74 years, you can probably sit out the next 74 years of UFO stuff and not miss anything. If they land, if they're for real, they'll be all over TV. It'll be the world's biggest news, and it'll come to your attention then. Well, however, the pendulum swung back in the 1960s when Frank Drake and Carl Sagan and others pointed out that although we now had good enough radio telescopes to maybe detect artificial signals at other stars. And this could be the basis for the first time of a genuine, realistic scientific search. And that was the start of SETI, Search for Extraterrestrial Intelligence. And it has been running new and better searches by lots of different groups and projects, which have been growing in range and sensitivity and depth of coverage by leaps and bounds ever since, especially in just the last 5 years. And I can go into detail if you want about that. The radio technology, especially the information processing technology, is absolutely extraordinary. The big project right now is called Breakthrough Listen, funded by $100 million donation from a Russian internet billionaire named Yuri Milner. It can listen to 6 billion radio channels at once with great sensitivity. Anyway, going on. SETI searches have also widened to look for optical laser signals. Maybe they could try doing that. You work through the physics, and that might be a reasonable way to communicate across distances between stars, just the way radio is, or infrared, the near infrared or mid infrared might actually be better than radio if the technology gets developed well enough. And people are looking for signs of constructed objects orbiting other stars. And other interesting possibilities that people come up with that are worth looking with. We've got a lot of capability now to do actual real searches, and so far nothing. Meanwhile, we've learned vastly more astronomically about things bearing on this question of life in the universe. Now, when I grew up and got my physics and astronomy degree, no one knew if other stars had any planets at all. One theory was that our solar system was something very, very rare and unusual that was caused by a very rare event such as a star passing very close by the sun early on and pulling out a whole bunch of matter which formed into a disk from which planets condensed. And that'd be like a 1 in a billion chance that would happen. But now we know that planets are common. Most stars have planets. This because we've now discovered and cataloged more than 4,000 planets around other stars, exoplanets they're called. And it turns out that roughly Earth-sized planets in the so-called Goldilocks zone for life, meaning not too hot, not too cold for liquid water, have turned out to be pretty common. We found out that most stars have planets, and you work through the statistics that you can get out of the numbers that we've got now, and it works out that there are probably a few billion, more or less, Earths in our own Milky Way galaxy alone. Meanwhile, elsewhere, biologists and early Earth paleontologists have found that on Earth, life arose practically as soon as the Earth's crust cooled, indicating that the origin of life process and progress is being made on this, that how life originated out of non-living matter. It doesn't seem to be a great mystery. It's a matter of details rather than the concept itself now. But the fact that it happens so early in life's history when it could have indicates that this process happens easily and readily. And biologists are also finding out how certain evolutionary processes tend to drive toward certain results generally. Most evolution works at random, but some things like eyes and nervous systems and brains seem to arise in parallel, independently of each other because, they work. They're really good ideas and they really help creatures survive. For instance, you look at pictures of an octopus's brain, and it has 8 lobes rather than our 2 lobes, because octopuses are 8-armed or 8-sided kind of. But my gosh, the last common ancestors we had with an octopus were clams, mollusks that didn't have brains at all. So here's a case of parallel evolution. Many creatures, such as other octopuses and squids and other cephalopods, have eyes that evolved to be rather similar to ours in how they work, even though they originated independently. So we're seeing examples of when parallel evolution happens and when things are just a matter of a one-time fluke. And it looks like things like central nervous systems and eyes and enough rudimentary thought to help enable a creature's survival, which has also evolved more than once separately. Think of insects. A grasshopper can think well enough to be a grasshopper. This suggests that these processes are pretty general, not rare flukes. So then, we know that we got a billion good Earths. They've been around for ages. We know that life probably forms easily. We know that evolution probably, even though it goes in random directions, some of those random directions are going to get pretty interesting in all likelihood. Nevertheless, all of these SETI searches to date have come up empty. The aliens have never come and landed. There's no actual signs of life that have been discovered among the stars. So what's the matter? And this has been leading to another pendulum swing back toward the idea that intelligent life is probably rare, or maybe extremely rare. One civilization, one technological civilization active now per 10 million galaxies is what one group of astronomers recently guessed and got in the news for. And however, this too is an overreaction. For instance, SETI searches are much better than they used to be, but they are absolutely minuscule compared to the radio, infrared, and optical search space yet to be covered. And search space means all the frequencies, all the points in the sky to look at, and various other parameters. The best estimate I've seen is that we've looked at about 1/1,000,000th of the actual search space to be searched before we can say, yeah, we've looked for aliens and haven't found them, and they're not there. Meaning there could, in fact, be dozens of exasperated alien civilizations beaming signals at Earth continuously right now, saying, hey, listen up, you guys. And we would likely miss all of them, even with these wonderful searches that you read about in the news. They talk about what they can do. They don't talk about what they can't do by the time it gets to the general news media. But we do know that there really is no low-hanging fruit to be found in the frequency bands that we have thought to be the logical ones to broadcast a hailing signal on. But what do we know about alien thought processes? But the bands, the frequencies that we've looked at haven't found anything. So there's no really low-hanging fruit to be got. And we didn't know that 20 or 30 years ago. But there's also one solid and important piece of evidence that we do have, actual real evidence that is in hand rather than guesses and studies that come up empty. And that is the fact that aliens are not camped out in your backyard right now and all over Earth. And that Earth is not a bustling spaceport for interstellar travelers all around the galaxy. And this is called, the fact that they haven't shown up here is called the Fermi paradox, named after Enrico Fermi, who asked the question in 1950, where are they? What do they do? Do they blow themselves all up? And by the way, where he had this discussion where he asked this famous question, where are they, among some colleagues, was in the lunchroom of a nuclear weapons lab. They were building the means by which our species could blow itself up. Nevertheless, it's called the Fermi paradox, and this is a real thing because, as people sometimes forget, a lot of people who think about this thing, and the media that educate people miss a huge important thing, and that is that cosmic time is extremely deep. And Earth, at age 4.6 billion years, is a relative newcomer among Earth-like planets. One estimate is that the average Earth-like planet, given the history of star formation in the universe and planet formation and the buildup of heavy elements that you need to make a solid rocky planet like ours with a surface that you can walk on, build up over time. The estimate is that the average Earth-like planet is about 6.4, 6.5 billion years old, roughly something like that. In other words, the average Earth has been around for about 2 billion years, 2,000 million years longer than the Earth has. So they have had all the time in the world to develop, if they develop at the same pace that we did on our planet, and to have a growing civilization if they don't go extinct for one reason or another, and build spaceships and colonize the entire Milky Way galaxy 100,000 light years across. And there's no rush. They could do it with spaceships that don't travel much faster than the spaceships we've got right now going around the solar system on chemical rockets. That's the amount of time that we're talking about. Incidentally, here's a scale model I like to use. If the 4.6 billion years age of the Earth is the height of the Prudential Building, or the John Hancock Building with a nice clean top, the dinosaurs appeared somewhere on around the floor of the top floor of the John Hancock Tower. The human species has existed for only a fraction of an inch above the ceiling, and all recorded human history is in the layer of paint on the ceiling of the top floor of the John Hancock Building. That's the kind of deep time that we're talking about. And aliens, if they arise on planets as fast as we did. They've had, 20, 30, 40 stories of the John Hancock building to develop beyond us and to get to us, and they haven't yet. It's not just that they're not here now, it's that there is nothing in Earth's fossil record that we have found to indicate that the Earth has ever been colonized by a highly advanced technological civilization before ours. From here on, if we go extinct, new species that arise in the far, far future will find all kinds of evidence for us. They'll find our poured concrete house foundations with rebar in it. They'll find all sorts of things in our former garbage dumps, and every place we leave trash. They'll find chemical signatures in all of the sediments being laid down all around the world, anywhere. Will be very obvious, but we're clearly the first, because that has not happened any time in Earth's history, or we would have seen evidence of it now. Yeah, maybe they could have come here and set up a short-lived colony or scouting expeditions, but they never colonized and took over the Earth before. And well, people might say they didn't find Earth. We've only been broadcasting radio for 100 years. However, we're also not only developing good radio telescopes that could theoretically pick up a powerful enough alien broadcast, we are also developing good enough telescopes and spectroscopy and whatnot to be able to actually see other Earth-like planets well enough to see that, to recognize that they have chlorophyll and they have an unstable atmosphere that must be driven by life processes. The Earth has been sitting in plain view, wide open, for the people with enough telescopic power anywhere in the galaxy, really, to see that this is a living, really interesting living planet for 400 million years. And we've been sitting here in plain sight, and they haven't showed up, at least in any great numbers that made a record. And let me see, I lost my place among my cards. Anyway, here we go. So what's really going on out there in the universe? Dozens of explanations for the Fermi paradox have been proposed, many dozens. In fact, at Sky and Telescope, I reviewed a book on 50 solutions to the Fermi paradox, ranging from the origin of life is extremely rare, or animals making the leap from being really smart monkeys who can use sticks to get termites out of termite hills and things, to being able to build technology like, spears and ships and things that, the Romans and the Greeks and the Babylonians and the Chinese had a few thousand years ago, is some huge, difficult thing that can't be done, or that electricity is something that and the discovery of that was a fluke. But no, it wasn't. Benjamin Franklin and Alessandro Volta, given the cultures that they lived in that had developed by that time, they had no trouble discovering electricity. It's obvious when you get to a certain point. Many other solutions have been proposed. One is the so-called dark forest idea that all species are so afraid that they might be destroyed by a more advanced one, who would be afraid that they would develop to become more advanced than them, that they would destroy any life or originating on any other planet. But everybody's so afraid of this that they all maintain silence, radio silence. However, as I just said, radio silence isn't good enough. The Earth has already been giving itself away, sitting out there in plain sight. The Chinese science fiction writer Li Jinxing, I think his name is Xijin, is pronounced, wrote a very popular trilogy called that explored this, but frankly, he didn't know his astronomy. But anyway, he proposed the idea of the dark forest, and that's one idea. Another is that they're not interested. We're so far below them that they're not interested any more than we are, and interested in, investigating worms in the ground, except that we do investigate worms in the ground. And also, if we're not interested. Is every single one of these creatures that evolve on billions of planets, every last one of them uninterested? It only takes one to colonize the whole galaxy and send self-replicating robot probes that build themselves out of material wherever they find it, and then spread on to fill up everything and report back to the message central. That hasn't happened. They all blow themselves up with nuclear weapons. Remembering where Enrico Fermi was, for instance. However, it only takes one to get past our dark ages point of civilization and developed a truly civilized, healthy culture that survives and is sustainable indefinitely. It only takes one. Or do they all totally go extinct from pollution or resource overshoot, as looks like a possibility, except that's not a possibility for our total extinction. No matter how bad it gets on Earth, there will be pockets of survivors who in, another 50, 100,000 years can repopulate the Earth back to many billions, just like the bottlenecks of prehistoric humans did 70,000 years ago. And again, it would only take one. So we don't know what's going on. Is there something that totally prevents interstellar travel? No matter how advanced you are, you can't fly to other stars. There's nothing that we can see that would do that. Heck, we're sending space probes out of the solar system already, and they're not hitting a wall or something. So is there something unknown and universal in biology that makes it extremely unusual for advanced animals to learn to manipulate their environment very well? So anyway, that's the basic state of play. You can take your own guess, and the fact is we don't know how common intelligent life is, or if it is out there at all. And why it isn't already using Earth as a grand central spaceport for at least the last 400 million years, since we've been sitting here just as a tempting plum to pick. And before we go into discussion, since we're only halfway through, I'd like to just list some common misconceptions people have about this whole topic. And this includes a lot of the news media as well. One, people often say that because we exist, here we are on a planet, and there are so many quadrillions of stars and planets in the known universe. Obviously, there must be lots of other intelligence life. How could there not be? And this overlooks the so-called Anthropic Principle that we are self-selected observers of ourselves. This is an interesting and slippery concept, but it's very important in a context like this, when you're considering or looking for something like yourself. For instance, suppose that for some reason or other, life is so rare that it exists in just one tiny, far remote corner out there of the known of the entire universe. Well, if that were true, the fact that we observe our own existence means that we are there in that corner observing it because it's us. So the fact of that we observe our own existence gives absolutely zero information about how commonly intelligence exists, whether it's, one per 100 stars or one per 1,000 stars or one per 50 zillion quadrillion stars. Another misconception, that finding nothing in SETI searches so far is somehow significant. Well, we've done all this looking and we haven't found anything. No, we've only looked at 1/1,000,000th of what's there. That's like saying, well, I want to look for elephants. I think there might be elephants in the world. So you go out and look around your front yard, and it's at night, you shine a flashlight here. No, there's no elephant there. You shine a flashlight there. There's no elephants there. I've looked all over for elephants. There aren't any. That's another misconception. in terms of the radio spectrum or the electromagnetic spectrum alone. Another misconception is that what we are listening for with all of these searches is leakage from aliens' own radio use, their own internal communications, whatever they're using radio for themselves, their equivalent of TV and audio broadcasts like we use radio and TV. And the fact is, no. Our own, Earth's own radio leakage is so weak by comparison with the directed signal that we could actually make if we want, that our best SETI searches couldn't detect another Earth, couldn't detect Earth itself as distance beyond a few light years, really, the distance of the nearest few stars. There are a few exceptions to that, like aircraft radars that track airplanes, give brief bursts in particular directions that might be picked up far more light years away if somebody was listening with the biggest instrument we have on Earth, which right now is the giant radio dish that the Chinese have built, which kind of replaces the Arecibo dish that America had for 20 plus years until it collapsed a year or two ago. But no, the only signals that we are realistically searching for are so-called beacon signals by civilizations that are deliberately designing a broadcast to be easily picked up. That means extremely narrow bandwidth, maybe just a few hertz out of many, many gigahertz in the microwave and mid-infrared spectrum where it's most efficient to do this. That's what we're looking for, is a beacon signal by others who want to make contact, who think, wow, there might be others like us. Let's team up with them. Let's find out about them. What can we learn from them? And we could do this ourselves, not in a serious way now, but say in the year 3000, we'll be able to broadcast our existence with a beacon signal powerful enough to be heard all over the Milky Way galaxy and more, by means I could suggest if we get into it, but not far beyond our own present technology. But we are looking for not to overhear their broadcasts, but to hear a beacon signal. Similarly, they're actually never going to be able to watch our own old I Love Lucy broadcasts that are traveling out there at the speed of light. It turns out that to encode a lot of information, like a television picture, a moving television picture, requires a lot of bandwidth. You got to spread your frequency way out over a lot of bandwidth rather than narrowing it into a tiny, bright, tiny, narrow bandwidth that's easy to find. In fact, the more information you cover with radio or TV, the more the signal looks like noise, unless you have the special technology like a TV set to decode it. So, for instance, our Earth's strongest leakage used to be from the big 500,000 watt radio television transmitters like the big 3 towers in Needham doing broadcast TV before there was cable. It turns out that most of the time, about half of that 500,000 watts is in a narrow carrier wave that's only about 1 hertz wide. And now that we're using digital TV, which is much better for a lot of reasons, and will be generally even for other civilizations, now that's going away. The carrier waves aren't wasting all of that energy anymore. It's all going into digital signal, which is broadband and looks like a hiss, a natural source rather than something that came from a radio transmitter. Another misconception, maybe we're the first. That's a solution to the Fermi paradox. Maybe it takes life a long, long time since the origin of the universe to develop, and we're the first. And no, turns out most Earths are old. The average Earth in the Milky Way galaxy is 1 or 2 billion, maybe more, years older than our Earth. So we're not the first, unless we're extremely rare. And another misconception is that once we find a signal, we can set up a two-way communication, and debates get going about, is this a good idea? Should we give ourselves away to them. They might come and invade us. Who knows what they might want to do. If we need to be real quiet and learn a lot about them first. I mean, look at what happened to the Incas and the Aztecs and the Native Americans in North America when they made contact with Europe, or Europe made contact with them. If the Incas had been smart, they would have hidden themselves as well as they could and sent a few representatives back on the ships with the Spaniards to really learn the politics of Europe and decide who we want to make contact with. And maybe the Spaniards aren't the best ones, and get some control over this. But again, we've been giving our position away just by the Earth being out in plain view as a living planet for a huge amount of time. And anyway, because with the fact that there are no low-hanging fruit, does mean there's probably nobody around for dozens or hundreds, more likely thousands of light years in any direction. We got all the time in the world to decide how to respond, and we wouldn't hear an answer back if they're 1,000 light years away. We'd have a lag of 2,000 years in every conversation between question and answer. So that is not going to be an immediate thing. Another misconception is that the first signal we find will probably be from relatively nearby. I mean, it's only logical, right? You'd hear from the nearby ones first, and the farther ones would be weaker and fainter, and we wouldn't hear them until later. And no, it turns out, for a variety of reasons I won't go into, do the math, the first signal that we hear. If it's news on the radio, astronomers at such and such at the Green Bank Observatory have discovered a genuinely artificial signal from a point out there in space, and it's been confirmed, and scientists are saying, yeah, this is the real thing, we've got it. You can bet long odds that it will be coming from an extremely powerful transmitter, extremely far away, maybe even in another galaxy. And I won't go into the reasons for this, but they're there. That means if you had a two-way conversation with them, you'd have to harness practically the entire power of the sun for your transmitter, and then you'd have a back and forth time lag in the conversation of many millions of years rather than just a couple thousand years. And actually, this means that wide field captures by radio telescopes of whole galaxies, 1 trillion stars at once, is much more significant for a negative result than examining individual stars in depth. And the last of these misconceptions I'm going to go to is that if we hear a signal, humanity will be able to decide whether or not to beam a signal back. And there should be some big international body, maybe the UN, to hold debates and come to resolutions and finally make a considered decision. Do we stay silent, or do we give ourselves away by saying, hey there, here we are, we hear you? No, because once the signal is discovered, and all of the scientists involved in this are committed to open information. Everything, it'll be known. It'll be announced exactly where in the sky, what point in the sky it's coming from, what frequency they are working. And once you know that, suddenly you can increase the efficiency of your signal back to them by many millions of times, so that anybody who can scrape together, any country that wants to announce themselves first, make contact with us. We're the ones who are really doing it. All of these other countries are awful. We're the good guys. Every religious cult, I won't say crank, every enthusiast in the backyard who has can scrape together a couple $1 million, can build a radio dish and blast that point on the sky at that frequency. So what'll happen is an uncontrolled response from all over the earth with all kinds of different motivations. It will not be a considered response, not that it matters anyway. So anyway, that's what I've got. I'm sorry I can't answer, is there intelligent life in the universe, or even what the probability of it is. There's every probability of it in theory. It ought to be all over the place in theory, but in practice, we don't find it yet, and we don't know why. So I guess that's the best I can leave you with. We could hope that we live long enough to see enough developments to get excited about. So, do you want to open it up for questions?
Sure. So anyone who is interested in making a comment, asking a question, you have a couple of options. You can wave your arm frantically. You can use the chat option and let us know, or you can use the reactions. I'm sorry, not that, the participant list, and go there to raise your hand. So I'd like to kick it off with one question or one observation, and maybe you covered it and I just didn't grasp it, Alan. Is part of the issue of not detecting any SETI, our imagination, our thought process about what that intelligence would be like?
Yeah.
We're anthropomorphizing it, making it sound like the intelligence is human almost, rather than something that's simple.
That's a really good question. How much of a life of the mind do we share with pretty intelligent seeming creatures like squid, who are not at all human? But what we do share across the whole universe is the same physical environment. The laws of electromagnetism, light, radio, all of that stuff. And the laws of sound, for instance, you can holler, but it's not going to get out of your own atmosphere, no matter how loud you holler. So it's not like they're going to think, oh, they can communicate among the stars by shouting loud enough, because they will know that sound can't carry out of their worlds. So it's not that. We do share the same physical world, the same physical universe, and the constraints on long distance communication and cutting through cosmic noise that they'll all know about if they have radio astronomy at all, no matter how they think, will be essentially a common language. Again, octopuses don't think the way we do, but they have cells and organisms and other parts of their organism that work a lot like we do. And yeah, they have common DNA origin from us, but whatever the aliens are, they will have a common origin in the physical world. So you can only take that so far. Although one solution to the Fermi paradox is produced is, well, when a species becomes intelligent and mentally capable enough, maybe they discover that there's whole dimensions in the multiverse outside of our universe that they can access. I mean, like Hindus, if you meditate hard enough, you can get to nirvana in some world that's not this world. And maybe they all discover this because this is part of the actual physical, real built universe or multiverse. And they all decide that's where to go. That's where it's really at. So they abandon this place. And that's why we don't hear them. I mean, this is thinking outside the box. And who knows what else there might be. But again, zillions of ideas like this have been proposed, but how do you get a hold of them? But they are, as long as they're in this universe, they're going to be constrained by the physical, quote, consensus reality that we all live in.
Thank you, Alan. It looks like we have a question from Rick Rosen. I don't know if you want to read that in the chat box.
How much of the total search space would we need to be surveyed before we can say with 95% confidence there's no life out there? How much longer will it take to reach that milestone? Okay. That depends on how much you're looking for the aliens Another factor is if any that we hear from will be extremely more long-lived than we have. They will have had a technology probably for millions and millions, hundreds of millions of years, just in order to overlap our own brief moment of cosmic time. If they appear and disappear, say, in 1 million years, that's, like an inch or so of the height of the John Hancock building. To have any chance of their inch of the John Hancock building overlapping us, they're going to have be existing and continuously broadcasting a beacon for many, many millions of years. If they really do that, if they really put their hearts into it and broadcast in lots of different ways and lots of different frequencies, we might get lucky pretty soon. Or if we luck out and think of what's a logical frequency that we would broadcast on if we were doing this. And the first example is, well, the strongest narrowband radio emission that naturally occurs, the things that radio astronomers will first discover when they first start doing radio astronomy at all, is the so-called 21 centimeter wavelength emission from hydrogen atoms in space. Hydrogen is the most abundant element in the universe. The 21 centimeter line is how radio astronomers first mapped the sky. So logically, the early SETI experiments, until fairly recently, picked like a narrow band within the 21 centimeter range of maybe the best that the instruments could do then was maybe of 1 million radio channels at once or 20 million radio channels at once in that one particular narrow area. And if we get lucky and, well, somehow hit on, oh, this is another logical frequency, another hailing frequency, and lots of people have come up with lots of logical hailing frequencies. Well, the water is so important for life as best we can determine, so maybe they've decided that to broadcast on the radio emissions, various emissions of the water molecule, because that's common and that's where radio astronomers will be listening. So it's hard to answer that question. It's, if you really want to answer it rigorously, it would be 95% of the trillions of pieces of the search space that have been enumerated. And that includes things like how much of the time are they broadcasting and do they turn off for a while? Do they just emit in blips, meaning you have to listen for a long while at one particular point at one particular frequency to catch it? Or drifting frequencies. There was a program called SETI at Home, which a lot of us, I think, participated in, using distributed computing, downtime on your own home computer, to do signal analysis of a SETI search signal collection at the Arecibo Observatory in Puerto Rico, the big giant dish, to look not just for steady broadcasts at one frequency, but look for drifting signals. Narrow signals are going to drift just because of the motion of the Earth. It's going around the sun. It's rotating. Both of things add Doppler effects. And if a transmitter is on another planet or is in space orbiting another star, it'll have frequency drifts of its own that are unpredictable, and they can't predict ours because they don't know where we are. So SETI at Home had the big strength of adding a new dimension of searching for lots of different frequency drifts. And it came up with nothing, but it was a hugely exciting and wonderfully valid and impressive scientific experiment. And in fact, it pioneered the idea of distributed computing. So now people on your home computer, you can go into the World Community Grid, you can go into BOINC, you can choose from dozens of things, doing medical research of protein folding and searching for prime numbers and all sorts of things like that to use your computer's downtime. And we got, at Sky and Telescope, we got a lot of flack for promoting SETI at Home because it is electricity intensive. This amount of computing, if you've got 1 million volunteers running their home computers all day and night, rather than turning their computers off at night, you're contributing a lot of carbon to emissions to the world. So we were telling people, at least turn off your monitors. So anyway, that's a long answer to a short question. Sorry.
Thank you. Peter Ash, you can unmute yourself.
Yeah, thank you. Thank you, Alan. Yeah, I was reading that a decision was made on November 4th about possibly funding a new space telescope specifically for the purpose of searching for exoplanets.
Yeah.
And possibly intelligent life.
Yes. Okay, yes. Again, this is a really exciting area that may happen in our lifetime. You had more to say?
Yes, I do. Please. Anyway, I have two minds. First of all, the scientist in me says, oh, this is wonderful. And then there's another part of me, let's say the activist, that says, okay, suppose we find some intelligent life and it's 2,000 light years away. And what does that do for us?
What it will do is a huge thing for human civilization. It will tell us you can survive. Intelligent life can make it. Because they will be much older than us, it means that we are not destined to go extinct. We are not destined to go extinct. If other civilizations can develop technology and survive for extremely long time, we do not necessarily, our future is not necessarily that we're going to blow ourselves up, that we're going to render the earth uninhabitable. That will be a huge boost to the idea that we have a future. A friend of mine in a rock group they've come out with a song that is becoming popular in the Extinction Rebellion movement and young kids. It's called "Oops, We Forgot," and it's about it's the boomers, the elders, and the other generations singing, "Oops, we forgot, we forgot. It just slipped our mind. Oh, we forgot. We're so sorry. We forgot to leave you a future." And what this would mean is that another species has proven that we can have a future, that intelligence does not kill itself off. Right now, you can make a case that a creature that develops into enough intelligence to gain enough technological power over its surroundings will kill itself off. Because, how long can we live with nuclear weapons before we use them? Nobody knows how long the half-life of nuclear peace is. That's one thing. Another thing is, even if we don't find any life, what we will find is, as just astronomically, we'll be able to characterize the planets in our nearby vicinity around other stars a whole lot better. Maybe they're all like Jupiter's and Mars gas giants, or Marses that are barren deserts, or Venuses that are barren hothouses, or it may turn out that there are very, very few planets that show chemical persistent chemical instabilities in the atmosphere like Earth does. Earth has free oxygen in the atmosphere, and it also has methane in the atmosphere. They can't exist together for long. Something has to produce the oxygen, otherwise it will ultimately, in something like just 16,000 years, oxidize things on the ground, and you'll end up like Mars with rust, iron oxides on the ground, and nothing but carbon dioxide in the atmosphere, unless there was life producing oxygen as a byproduct of living plants. Methane wouldn't last more than a few centuries unless it was being produced by ongoing processes, and the only really serious one on Earth is decay of organic matter. If we find another planet with free oxygen, that'll indicate there's something like photosynthesis happening. And if there's a mixture, and the oxygen-methane mixture that we've got is just one example of many, if we find that, many have been proposed. If we find a planet with a high chlorine atmosphere and a high something
What is
else.
your question? I can type it to Ellen.
No,
Yeah. Anyway,
say it twice.
Okay.
I'll cut off there. Just astronomically, there's a whole lot of really cool stuff to be learned. Never mind life, or even if planets all come up barren. Okay, I'm sorry to take so long.
Go
Thank
for
you.
it, Lois and Brown, or you want to talk? You want to say?
Yeah, I'll just ask. Alan, I've been wondering how many kinds of silly questions and pretend sightings of creatures from outer space are happening around our own planet. In other words, what are we dealing with worldwide with so-called people venturing here from other planets and so on? And does science and does the government have to spend a lot of time and money just chasing them down?
Well, the Air Force.
Yeah.
The Air Force does spend quite a lot of time and money trying to chase things down, and they haven't found anything. Anything other than unknown, secret aircraft flown by other countries,
Yeah.
weather balloons, weird atmospheric phenomena, and a whole lot of things like people seeing Venus in the west at dusk and say, that star, that thing wasn't there. It's not moving. It's not an airplane. It must be hovering. It's a flying saucer. There's so much of that. And what people would call sky and telescope and say, I saw this thing in the sky last night, and it was there for a while, and then it went away, and it was a point, and the fact is there is just so much junk up there now. There's no tracking it all down, and if you really want to try, you can go online and look up a satellite finder, and it'll give you, if you tell where you're located on Earth, the direction in the sky you're looking, and the time you're looking, it'll tell you all the satellites that are going by there and what you might have seen. But there's all kinds of junk up there. I mean, okay, not to tell tales on my kids or anything, but I heard stories that some kids had a cool idea of making a hot air balloon out of a big plastic garment bag, you get from the cleaners. They hung a wad of burning cardboard soaked in candle wax or something, set it alight. It made a hot air balloon that went floating up into the night sky. And God knows the fire hazard they created. That got UFO reports. But nothing. The thing is, nothing ever comes of these things.
Yeah.
But we've been through 74 years now since the first great flying saucer flap, and nothing has ever come of them.
Thank you.
But you had silly. Are there silly questions? And I just want to say right off, an honest question is never silly. If people don't know a question, no matter how little they know, no matter how silly the question may seem, there are no silly questions.
Rick Rosen had a question in the chat. Do you see it?
Let's see. What about Oumuamua? Oumuamua. Yes. Oh, yes. That was the first interstellar asteroid that came out of deep space and flew through the solar system. And it turned out to be, because it was tumbling, rotating, by the way it reflected light, you could only see it as an individual point, a speck of light, but the way it brightened and faded as it rotated indicated that it was much longer than wide. So, some asteroids are like this, or might be like this. It was not terribly big, I think a few 100 meters or maybe a kilometer or two long. One of the SETI programs did take one of the world's best radio telescopes and really gave it a very deep search across a lot of wave bands, and it was completely radio dead. There was no electrical technology going on at it. It's not a spaceship that does it. It was, in fact, they said if there was anything there that was emitting as much radio as a child's toy walkie-talkie, they would have found it. And it was radio silent. And in fact, it started to emit gas as it came near the sun, like it was had frozen materials. Basically, it was a comet, a rock, either an icy asteroid or a rocky comet. It's you take your choose, pick how you define it. But interstellar asteroids had been expected for a long time. We know that the sun, when it formed the solar system, expelled the planets, flung out from the solar system to fly forever through distant space. Many millions of small asteroids. Other stars forming their solar system should do the same. It should be only a matter of time before one of them comes through our own solar system. And now that we're getting really good asteroid searches online, yeah, they found one, and they've actually just found another more recently called Comet Borisov, which actually does have enough icy material that is, as it gets nearer the sun, is evaporating, and that's on an interstellar orbit. So these were expected, and now we're able to find them.
Thank you, Alan. Yeah, I don't see any other hands up. Do you see anything, Webb?
Can you hear me?
Yes, we can hear you.
Yeah, no, Zoom has wigged out on me. I don't even see my own controls, so I'm not touching anything, but I'm afraid I can't help you right now.
Okay, I don't see any hands up on the additional screens. So
I think we're done in that. I want to really thank you, Alan. It's been thought-provoking. And for those people who are still, did you have any final comments for the audience, Alan? I didn't want to cut you off.
Okay, yeah, okay. This is a great study, great area for scientific research. Don't let anybody tell you, oh, we've looked and we haven't found anything. It's a waste of time. No, these are fantastic experiments that are being done. They're so wonderful, and they could succeed at any time. We don't know. I mean, we could wake up tomorrow morning and the Green Bank telescope running the Breakthrough Listen program could have found something that has been confirmed by the Chinese and by the Europeans, and it is a steady broadcast that is flashing prime numbers or something like that from a star 6,022 light years away. We could see that in the headline tomorrow. I'm not counting on it, but it's possible. And in the long run, in the really long run, the question of assuming we can survive the next few centuries and reach a sustainable, steady state that will ensure humanity's future, in the really long run, there is no bigger question facing us than whether we are alone and the galaxy is ours to colonize, or whether it's already pretty full and we're just the latest new citizen to show up.
Great. Well, thank you, everybody who's been on the call and participated. I just want to give folks a preview also. In December 5th, we have another Lyceum scheduled, and Bradford Connor, our own Brad Connor, is going to be presenting, he calls it the Bells of Christmas. And just a preview, he says, some of the most significant moments in history have been defined by the presence of bells. Besides the obvious connection with music, more than that, bells are part of everyday life. And he goes on to say that he'll be speaking to poetic, how it has inspired poetic masterpieces, and even has power to tell us when an angel gets its wings. So in any case, Brad Connor has been our music and choral director for 17 years. He's a vibrant speaker, and it should be wonderful. In January, we have Rebecca Neal, who is an attorney here in the Bedford area. She has a couple of topics she may choose from, but that's January 9th. So we're not stopping in December. look forward to seeing all of you again, and look for announcements about Future Lyceum on our website. That's aabedford.org. Thank you, everybody. Thank you, Webb, for all your assistance, and thank you, Alan.